Hello and good afternoon, everyone. I'm Dave Rubenstein, Editor-in-Chief of SD Times. I'd like to welcome you to today's session. It's called 5 Steps to Eliminate Database Change Risk in the Application Release Process. As many developers have learned the hard way, whenever you move a database from a development environment into production, there's a high probability that that change will break the application or result in a critical loss of data. That's why managing change is so critical. With us to talk about this today are Robert Reeves. He's the CTO at a company called Datacol. They do database change management. And also Carrie Benge, Vice President of Operations and a technical sales guy. I'd like to discuss the agenda briefly today. They'll be laying out ways to eliminate manual scripting errors, provide transparency to schema management, and a whole lot more. Step by step through today's presentation. First, they're going to talk about the results of some research they've done, or that has been done, into the cost of database change. They'll be addressing database deployment challenges, talking about those steps to eliminate risk due to change. They'll provide an overview of Datacol DB, which is their offering. After that, the session will go into a live Q&A for the attendees. What you can do at any point during the presentation is type your question into the Q&A panel, which is located to the lower right-hand side of the interface. Hit submit, and we'll get to as many as time allows. Then we'll hear a little more about Datacol, and we'll wrap up. So to keep things moving right along, I'd like to introduce now Robert Reeves, again, CTO of Datacol. Robert, take it away.
Thank you very much. I appreciate it. And thank you all for joining us today. I know your time's really valuable. So hopefully what we're going to discuss with you today is going to make it worth your time. As was mentioned earlier, we engaged a research group out of Boston to really look into the challenges that companies are facing today around database change management. And all of this research is stuff that we had commissioned, and this is a result of a very large number of interviews that we've done directly with IT directors, managers, VP level, C-level folks. And one of the most startling things that we found is that of the people that we spoke to, they said that 78% of the time that they make a change to that database, either moving code from development to production, changing a production database, or updating the schema there, 78% of the time that will result in either the application breaking or a loss of critical data. Now that's pretty scary. When you think that almost 4 out of 5 times we make a change, we're in for some trouble. And we feel that, well, not that we feel, but what we found out is that it goes a little bit deeper than that. We're seeing that companies are using more and more applications. These are typically custom applications that they've built to support their business. They're using not just one database vendor, but at least 3. There's lots of changes going through, and it takes a lot of developers to support these applications. And it requires a high level of skills and sophistication to support these applications. Now, we all know that there is a problem here, and we try to get at the root of how do companies address these issues today. And one of the things that we found is that people are adopting agile development methodologies more and more. Unfortunately, this doesn't seem to be fixing the problem. We saw the same number of issues, or the prevalence of issues, whether a company had adopted agile development methodologies or had not. The problems are slightly different, but they are still significant. So it seems that agile is not a magic bullet. It's not a panacea that can really solve this problem. On top of that, 2/3 of these organizations do have some sort of DBA tool to resolve this issue, but unfortunately, they're still having critical application failures due to database changes. So it appears that agile development methodologies and the tools that exist today are not solving the problem. Beyond that, we found that companies are willing to rate this an 8 out of 10. That was the average number that we received for sense of urgency, and that's pretty significant. So our belief is that it's time to resolve these issues. We think that manual scripting is a problem. We think these changes should be automated. We think that people that are making these changes should have the opportunity to be able to see the impact of these changes, what the impact of those changes are. And instead of focusing on this blocking and tackling, we think that the folks that are struggling with this issue today should be focusing on more strategic projects that directly impact the bottom line of the business. So let's kind of get a little bit further down in the weeds and talk about how people are updating the database today. So, what we have here is a very common, develop, build, test, release cycle here. This is very common, and this is what we do. We write code, we build it, we test it, we, lather, rinse, repeat. And eventually we get to a point where we have some sort of release, some sort of atomic unit for our code that will be pushed out to our QA environment, production -1, production environments, and so on and so forth. This is pretty much a solved issue, when we start talking about the code that we push out to our environments. Where we start to run into challenges is when we have, the addition of those database changes. And because of the nature of a database, and because of our reliance on SQL scripts today, what we're faced with is understanding in what order and when to apply these SQL scripts. With code, for example, Java code, it's pretty easy. We can copy out, deploy a new EAR file, and copy over the existing one. We simply can't do that with a database. And so what that leads to is questions as to which SQL script do I need to run. So in this example, it appears that we've already run SQL script 1 and 2, and we just need to run 3. That knowledge is typically tribal knowledge. It's just stuck between somebody's ears or in email somewhere or a wiki or something like that. Now that's pretty manageable for one environment, but when we start to add more and more environments, determining which SQL script needs to run is very problematic. So in this example, it appears we just, we don't need to run 1, but we need to run 2 and 3. And understanding that is problematic is one way to put it. Beyond that, we also have the challenges of manual changes that are done out of process. And we see this a lot where we might have a change that gets pushed out from dev to QA, it doesn't work, and a developer, because they have access to the QA environment, will be willing to add a table that might be missing. Well, when that release is pushed out to production, we run into the same problem again. So these manual changes, being able to not only prevent them, but also to be able to identify what they are, is very complicated for folks today. Now, this status quo, that leads to quite a few challenges. One, as I discussed, is just synchronizing those environments as we go through the software development lifecycle. But to do that, to move these changes from one environment to the next, is typically a manual process, or we have some sort of internally developed scripts that we have put together ourselves. That is normally tied to a group or a specific application. It's very difficult to leverage those for new applications or other applications. What that also leads to is kind of an inconsistency of our configuration and migration processes. And being able to identify these changes is very time-consuming. To identify the impact by looking at a SQL script, they're typically pretty opaque. They're difficult to understand, and unless you wrote it yourself, you don't have an intimate understanding of what the impact of that change is. What all this leads up to is not just the technical challenges that we're dealing with, but it has a direct impact on the business as well. When we are dealing with manual changes, it leads to a linear relationship between the resources that we require when we increase the number of applications. It also, because we're relying on manual deployments, it doesn't allow us to very quickly roll out these incremental changes. And that stops us from getting out releases faster and being, as businesses being attuned to what our customers are asking of us and providing them the features and functionalities that they need. This leads to a whole host of other problems. I'm not going to read off them. I think you can see them on the slide. But what we've identified here with our research is that these technical challenges have a direct impact on the business, and we feel that's one of the largest areas of opportunity that businesses can address today to directly impact their bottom line. So let's talk about what we think is the best way to approach this problem to resolve it. And the first thing that we'd like to suggest is to treat our database changes as a Tier 1 artifact. Now, what that means is not just simply checking that those changes into source code control, into the same repository where our code comes from, but also to be able to take advantage of our branching and merge strategy that we use for the code. What this does for us is that immediately synchronizes those database changes with the application code. We are no longer in the business of identifying a version number of the application code and finding the corresponding version in the database repository. What that does is once we have the database changes in the code aligned, whatever pops out of the build system for application version 1.7 is the same for the database as it is for the application code. This allows us to leverage all the things that we're doing with our code repository to benefit what we're doing with the database. And it really eliminates a lot of guesswork in identifying which change goes where. We think the second step is to really understand the state of the database. We need to understand which changes have been pushed out to that database, because that will lead us to being able to answer a question, what changes need to be pushed? We feel that having a model-based, database-agnostic, platform-independent approach is the way to go. We need to have something that can work across all of our database vendors, whether using Oracle, DB2, MySQL, Postgres. We need to have something that is going to be the same across all of these platforms to really take the guesswork out of what is the state of that database? What do I need to do to that instance to get it ready for my application code? The next step, we think, is that database changes should be an atomic unit, that these should all come together as one, so that we don't, that we have a collection of atomic changes, but that they are broken down into their smallest units so that we can really understand what these changes are. If something fails in our deployment process, it's much easier to identify a specific change than an entire SQL script. I think one of the challenges of writing SQL is that if your SQL script fails, it's very difficult to, one, identify what the issue was, but once you've identified that, to be able to take steps to either roll back the previous changes or go forward is very complicated unless you have these changes broken down into their, the smallest change that you can. When you do that, it really speeds your ability to roll back changes and to get back to a previous version very quickly in case something goes wrong. And as we've seen from our research, that happens 4 out of 5 times. This is one of the things that we think is very important, because often IT is focused on issues or resolving, shortening their mean time to resolution. Being able to, once a problem is presented to IT in the form of a ticket or something like that, to be able to quickly resolve that issue, to get to resolution, and to help our customer. But we also think a more important metric is mean time to innocence, MTTI. We found that because database changes result in failure so often, that the database becomes the first place that we look for issues. And it's very important to be able to, with your change management strategy, to be able to quickly prove that the database is not, in fact, the problem, that it could be the network, it could be the operating system, the problem could be between the keyboard and the seat. A lot of other places these issues could be, but instead, because we're unable to shrink that mean time to innocence, it results in a lot of firefighting around the database to prove a negative. A lot of scrambling to say the database change is not at fault, and to get other people to look at other areas in hopes of finding resolution. Now, finally, we think it's very important to be able to forecast the impact of your change. It's, to have a script that says that we're going to drop a table or to change the data type of a column, these are, potentially disastrous changes. And if we are just simply looking at a SQL script to identify these things, there is a huge potential for us to simply miss them. We think by not only understanding objects that might be destroyed, but also to understand the impact on the data is paramount to getting a handle on your changes. By doing this, by being able to quickly understand the impact of this data change, we feel that that's going to accelerate your release process and speed your ability to get your new products and new releases out to market and satisfy your customers quickly. So for that, now that we've kind of gone over a few slides here, Carrie's going to take us through a more technical view of how we resolve these issues using those 5 steps at Datical.
Great, thanks, Robert. I'm going to spend just a little bit of time on one slide, then we're going to go to a live demo so you can actually see Datical DB in action. Robert's kind of already articulated the problem that we have here, and where Datical really changes the game here is by treating your database configuration as a Tier 1 artifact, as a peer with the application code. Matter of fact, we recommend that the database model lives with the application code. That way, as Robert mentioned, you can support your branching and merging strategies, as well as doing lots of things that we're going to cover in the demonstration. So this simplifies. I don't have multiple database scripts to manage. I don't have to know what repository they're in. I know that for this release of this application, here's the database model and the way the database needs to be that represents and supports that application. So that's the first key thing is, being able to treat that artifact as a Tier 1 artifact of the database. Now, the way kind of getting into the nuts and bolts of things, how Datical works, when we define a project in Datical, we establish a deployment plan, which really tells us the route that the database changes are going to go through the application release lifecycle. So it may go through, dev, QA, prod -1, prod, and so on. And then there's the change log or the model, which represents how that database should look at a certain point in time. So the unique difference of this model is this change log is comprehensive. It has the entire state of how the database should be at any point in time. And as I evolve the database over time, I'll add an atomic unit we call the change set to the change log. So the change log is always all-inclusive. And from that, we're able to do lots of things that are very challenging to do with SQL scripts. For example, differencing the databases, knowing exactly what state they're at, because typically in a multiple staged release process, the databases are at different states, and that's actually a normal thing, but being able to understand where they're at a given point in time and how to get them to the next step, that becomes the challenges. And by taking the model-based approach that Datical DB implements, makes it very easy to do that. The connection between the deployment plan and the specific databases we call the Datical DB engine, which is really the brains of the operation here. It knows how to take that model and basically apply it to those different databases and stand up that database or incrementally adjust that database to fit the model or to fit the model, -1, depending on what you're currently doing at that time. Based on this platform now, there's capabilities which make all this become a reality. For example, to be able to just snapshot and baseline a database as it is today. So grab its configuration, pull it into the Datical model format, and there we're able to, manipulate the model. We're able to do things such as compare models. I can compare dev to QA or QA to production or dev yesterday versus dev today. So a lot of flexibility there in having this model-based approach. Forecasting is another big part of that, right? How do I know, how can I sanity check my changes before I just, pull the trigger and run the changes? Because we use a model-based approach, we're able to basically take the model of the changes you want to make, look at the live running database of where you're going to apply that model, and tell you, these are the things that would happen if you deploy today. You would delete data, or you would, truncate data, or whatever the problem would happen there, and alert you to any potential problems you may have by making that deployment. A lot of our customers, they'll use forecasting during the week as they're evolving what the databases should look like, and once they're comfortable with what forecast is doing and they know it's going to do what they want it to do, then when they hit that release window on the weekend or whenever the release window hits, the confidence of it happening successfully goes up tremendously, and they actually stay within their windows a lot more often than they leave the windows now. Another feature, by using the model-based approach, we're able to implement rollback. There's really several ways of doing rollback. There's, of course, non-destructive rollback, which we will do for you automatically, where if Datical adds a column and you want to come back and undo that and roll that back, as long as there's no data in that column, we'll automatically undo that operation. Once we sense there's data, then we won't automatically roll that back. We want the customer to intervene at that point and let us know how that data should be handled at that point, because we don't want to automatically delete data without you being able to define, yes, it's okay to do that, or no, I want to define a backup strategy for this data before I blow it away. So rollback can be very powerful, but we also can be very safe the way we've implemented that. Now, all these operations, that as we're managing the database, as we're evolving the database over time, all the things these are tracked and audited in a nice history, which gives me details of who made what change to the database, when they made the change to the database, and why they made it. And so now I have a complete audit trail, which grows over time, so I'm able to watch the evolution of the database from an auditing and tracking standpoint. Several ways to interface with the system. The first is through a graphical user interface, which we'll see in just a minute here. And the second way is through a command line interface. So most of the functions you see me do through the user interface are completely available through the command line interface, because we want to be able to play well with others. We know the database is just one, it's an important part of the release process, but it's one step in the release process, right? I need to make changes to ears, to wars, to jars. I need to deploy those. And so we want to make sure that we fit in with bigger processes for deployment, for example, to integrate with your deployment tools from an operations standpoint, and even your build tools from a development standpoint. Then with our next layer of integration is through what we call them integrations. These are deeper, couplings to core products that customers drive us to integrate with. So we have a deeper and richer integration than just calling our command line interface. For example, like tools on the Hudson, Puppet, and some of the other tools out there, we have a deeper level of integration just to make a more tighter solution there. So that's it. We're going to cover on the technical slides. One last slide here I want to leave you guys with, kind of what are our customers seeing from the business value? Really what they've come back and told us that, they're able to eliminate risk. They're able to, feel more confident when they make changes to the database. They're not going to break the application because we're able to, forecast and sanity check that. Scaling operations where, lesser skilled labor now is able to make database changes without having to be, database, the gurus. The junior level people can do that, and of course all that leads to an improved quality of service, reducing time to market. And then achieving compliance goals, we're starting to see this a lot more, where customers are being asked to, be able to provide audit trails of other database changes. And that's been kind of elusive and hard to get that information now until Datical, just because we do that for you automatically. So with that, let me switch gears here and move into a demonstration of the product. Give me just a second here. I'll need to switch over my display to... All right. So hopefully everybody's seeing the user interface right now. Over on the left side, these are the projects that this Datical user is managing, and you can organize your projects based on line of business, specific application, project, whatever. Very flexible there in the organization. But what's key to that then is I define the deployment plan, which really outlines the path of those database changes as part of releasing those changes. And here in this process, I just have a dev, QA, and production. And over on the right side, I can see more information about those environments. Even just a quick visual, I can say that, hey, the dev environment is up to date, it's green. QA and production are not being managed by Datical right now, and so they basically are empty databases. And now, but I'm going to build those databases real quick and start making some incremental changes. Next thing I want to talk about is the change log. So the change log is the model. It tells us how the database is configured and what incremental changes have been made to it over time. Where here I can see I've created tables, added primary keys, created views, modified data types, loaded data, inserted data, and my last change I made was change 83 where I inserted some data, and here that correlates to where the development database is at. Now let's say we're ready to deploy a new QA environment. We need to stand up a fresh database that matches the application we're about to test. It literally is as simple as hitting the deploy button. I can hit a deploy. We basically read the change log, start applying each of these changes to the database, and then we have now a database in QA that stood up with our initial static data, and now we're ready for testing. That's very nice for just standing up quick databases for testing. Now let's say we get into more of a rhythm of making incremental updates. Let's say there's a new product feature coming out, need to add a column to a table, and so the first thing we can do is we can create that change. We call the individual changes or change sets. And ID is just an arbitrary, title that you can put in. You can have it be whatever you want it to be. I like to use a numeric sequence on mine and just a little comment. Who's making the change? Context is interesting, where if you have multiple development projects that are all working on separate databases, and then at some point they have to merge together to come together to work on one integrated database, contexts are very powerful to manage those different projects. The reason we like to do that is you may have project A, B, and C that are working together on separate databases, but at some time you need to merge them before you release. And now you come to the release cycle and project A is not ready to go, but B and C is. I can use context to know which database changes to pick up, so I can say only pick up database changes for project B and C, leave project A alone because it's not ready to go out. So it just makes it easier now to manage my database changes, very similar to where I would manage code changes, like tagging code and setting up releases that way. Now the changes that I can make just from the user interface is to be able to create new objects, modify existing objects, or delete objects. Here I want to modify an existing object. I want to add a column to an existing table. So I'll select Add Column. We go look at what tables are out there available, and we see that there's a vehicles table. I want to add a column called Model Options. And I want this to be maybe a varchar 64, and I want this to be not null. And so I hit next here, and we capture that change. And if I needed to make more changes, I could keep going, hitting the next button, and keep looping through the wizard, adding those changes. In this case, I'm done with this change, so I'm going to hit Finish here. And you see that we've added the column to the change log. It's at the very bottom. And now when I connect to the current databases, I now see that they go to yellow, meaning that they're managed by Datical, but they're not up to the latest change, which may be a completely viable state, but it's just nice to be able to, within one click, see where I'm at as part of that configuration. Now we get into where we can show some forecasting, where I can see, well, what would the impact of this change be? This becomes becomes very valuable when, development has that new release. They hand over the application. We're going to drop the new EAR file in. And, oh, yeah, here's a bunch of SQL scripts to run to change the database. Instead of doing that now, handing over those SQL scripts now, they hand over the model to whoever is going to deploy it to that next level, whether it's QA, production, and so on. And now with that model, I'm able to do a forecast, which is going to look at compare the live running configuration to the model that they want to apply to it. And so I can have a sanity check what development's handing me before I pull the trigger, basically, and deploy those changes. So let's do a forecast here and to see what we would do. Forecast works very fast as it's doing all the configuration and comparisons in memory. And here I can come back and see, well, it looks like we're going to change. This model is going to make one change to the vehicles, or one table change to the vehicles table. The change will affect 6 rows. No data will be deleted. And I can dig deeper and see that we're adding a column called model options of a var chart to vehicle tables, which that would affect 6 rows because now each row has a new column. But there is no data problems there. So number one, I feel safer now that they're not deleting data. And then I can view look at a visual standpoint and see exactly what the changes here, where I can see, well, we are adding a column called model options, and it's a varchar. And now that I'm comfortable with this now, I'm confident that this is not going to cause, havoc and destruction. We can deploy this now to this environment. Deploy report better look just like the forecast report because the only difference is one applies the changes, one just simulates applying the changes. And so I can go back now and see that I'm at the current latest of the change, however, QA is still one behind. Now let's say, for example, development says, okay, we're ready now to release this to QA. So they've handed over the model to QA as well as the new application. And QA could easily, they could forecast that. We've already done a forecast, so I'm going to skip that step here and just go straight to deploy. Let's deploy that. So now we've taken the QA database, quickly updated it to where it needs to be to test the new application. And now, I can go back and look at history, which is kind of interesting. It shows me how this database has changed over time, what changes have made, who made the changes, when they made the changes. I can use the tag column to associate release tags of the application or JIRA tags, for, bug defects that may have been fixed with this. I can use that tag column for multiple items that I can help, augment the management of this. Exactly the changes being made here from a database standpoint, and any comments, if people are nice, to add comments, or I can enforce where they do have to add comments if I want to. But that is a nice history, right? I can see how that database has evolved over time. Now let's say development came back to me and said, hey, QA, we kind of let the code out a little early. We're not ready for you to test this. And so QA wants to continue testing back on the old configuration of the database. They can literally just say, let's roll back, and let's go back to change 83 because that's where we were testing that version of the database with the application. So I'll select change 83, hit finish. Now we can see we're back to that version of the database schema. So now QA is back in operation, testing the previous version as they were before since development kind of threw something over the fence a little too early. And all of this is managed and tracked now, so I'm able to see how the teams are working and what changes they're having to make and when they have to roll back and stuff like that, because that is all tracked here. Now, the last thing I wanted to show is, how do we catch, changes that, I like to say they sneak in, right? Or maybe, somebody didn't use Datical, they went straight to the database. And I want to be able to have confidence that I know how my database is configured. So the next thing we can do is we can compare configurations. So here I have a couple of snapshots of a database, one that I took today and one that I took yesterday. Things were going well yesterday. I'm seeing some strange things today. So the first thing I want to do is, as Robert mentioned earlier, right, I want to get to that mean time to innocence, or figure out that maybe I am the problem, but confidently know one way or the other. So by comparing these configurations, here we simply look at the configurations, and here we're looking at how the Datical model represents itself. I'm able to quickly see that there is a difference from today and yesterday. And yesterday there seemed to be this table called model description, which does not exist today. So that tells me that something has come in outside of the normal process and made a change to our database. So I can now catch that. I can revert it back to where it should be. I can, whether I need to remove model description from yesterday or add it to today's configuration, I have now the flexibility and the knowledge to apply that. So with that, that's really kind of the demonstration that we were going to want to cover today. I think next we're going to open it up for some question and answer.
Okay. Very good presentation. Appreciate that. Showed a lot of really interesting stuff. And already we have a couple of questions from some of the attendees. Before we get into it, I just want to remind everybody that to ask a question now, you just go to the Q&A panel on the lower right-hand side of the interface, type in your question, and we'll answer as many as we can get to. Okay. So the first question would be, does Datical DB use agents that have to be installed on each server?
Well, thank you. It's a good question. The way we connect to the database, well, first of all, let me say no. We don't require agents. The way we connect to the database is using the native client that the database vendors provide us. So we are speaking directly to the database using their the method by which they would like to be spoken to, and that allows us to it doesn't require us to have our customers install agents on the database server or do anything weird or strange to the firewalls. If they can connect to the database using any of their command line tools, we can talk to it as well.
Mm-hmm. All right. And another question that we have, this was interesting, and I kind of thought this was very cool too, that whole forecast feature and getting everything in line with the model. But the question is, does the feature only work for the production environment, or can you use it for any environment?
Forecasting actually works for any environment, and yeah, our customers are finding that to be an extremely powerful capability, basically to keep them from stubbing their toe in the release process as far as related to databases.
Right. Right. Now, that whole impact analysis of changes, maybe you could just get into that a little bit for me. That seems to be the critical piece here, so that you're not implementing changes without having some sort of an idea of what the impact of that change is going to be. I guess that's what forecasting is kind of all about.
That's exactly what forecasting is all about. It's because when you make changes to the database, sometimes, as Robert mentioned, we have a lot of customers that the database changes are lots of SQL scripts, and it's really hard to read through the scripts, especially if you didn't write them, and really understand what is this really going to do to my production database. Somebody else wrote it, and I'm supposed to apply it, and it's so easy. Human error, right? I missed that one word that was very important. Right. So being able to, visually run the forecast and seeing it color-coded, red means you're going to delete something, just helps establish the confidence that as we make these changes, we're not going to break something.
Mm-hmm. Right. Okay. Looks like we have a few more questions coming in from our attendees. I'll get right to that now. Again, one of them is, can you set up permissions for who can access the environments, developer versus QA versus production? For instance, developers can only access development, or are permissions available there?
Yeah, absolutely. I mean, from the demonstration, I just showed all three environments in one view, which is actually a valid view. But from a true implementation standpoint, when you roll out Datical, you'll only have, like a developer will only have view to the databases that they're allowed to manage and production and so on. What is the common artifact is that model which they will share. So they won't share the database connections. They will share the model. So development will hand the new model to production. They'll have no idea how to connect to the production database. Only the production people will know that.
Mm-hmm.
Yeah, I think, this is Robert, when you look at, how environments are set up in companies today, typically the folks that are in development just don't have access to those later environments, and vice versa. The folks in production might not have access to dev environments. That is already in place today, and we feel that that's not something that we should take advantage of and not require our customers to do anything strange and unnatural. They already have these things set up today, and these environments, and maybe they're using VLANs or just username and password, those sorts of things. We just leverage those. So we don't require, certainly a Datical server to set up to manage these connections. We think that changelog, that model, is the thing that's going to be passed around, just like the EAR file or MSI file or whatever you're writing your code in. That is deployed alongside this model.
Interesting. So Robert, let me just ask you then, how does that all fit into, like, we hear people more and more these days going to these DevOps types of environments. So how does this fit into that type of a scenario?
Well, I think it fits in well. I'm a recovering software configuration manager, so it's something I've been struggling with since the late 90s. Look, I think at the end of the day, it's all fine and good that you want to create a mechanism by which you can take artifacts from dev and push them out to, all the environments all the way up to production. I think it's great that both sides of the house, development and operations, are starting to leverage each other's tools. But at the end of the day, if you are buying into these DevOps frameworks or you're creating your own, you are still going to struggle with database changes. We think that this, reliance on SQL scripts is frankly a bit dated, and it's very procedural based. We think that if you're committed to adopting a DevOps strategy, you really should solve or ask yourself how you're going to solve your database change challenges ahead of time. Because even if you adopt a DevOps strategy and you're lean and mean, high speed, low drag, you are still going to be slowed down by your database changes. And that will be the critical chain as you move forward and adopt that strategy.
Very interesting. Good point. Okay, getting back to the questions, we have another one from one of our attendees. When you roll back changes, is there a trace left?
Well, that's a good question. It really, I love answering questions. It depends. Now, if there are two types of rollbacks, as Kerry was talking about, that we do. One is sort of a automatic rollback. And these are rollbacks that deal with creation, non-destructive changes. And so if you think of as far as a trace, no, there will not be a trace in the database. We will not leave orphaned objects in there. If we create a table and you want to roll it back, that table will go away, unless, of course, there's data in there. Now, if you are trying to do a more complex rollback, let's say I've created a table, I've put some data in it, and I want to provide the mechanism to roll that back, but I want to save off the data somewhere. We do provide a mechanism for more complex rollbacks. So instead of dropping the table, you can tell Datical DB to copy the data to another table somewhere. So you just have that for posterity. But as far as other traces, we're not leaving orphaned objects. We're not going to leave them in the database. But there is going to be a trace from the perspective that we do have reports, and we certainly have it stored in our history table in the database.
All right.
So I think those are good traces, but no bad traces.
And that's what people want. So that's good. All right, the next question. So the question is, how would you support larger data sets with millions of rows of data, and how would the performance be during the data comparison from one day to the previous day?
Well, good point. And let me point this out. We do not deal with the data itself. All right. So when we start to we focus on the structure of the database. All right. So things like if there is we're dealing with very large data sets that are in these tables, that is not going to slow us down. We feel that there are quite a few tools already in the market for comparing data. We still believe that, and the market has shown us with the research we've done, that people are still unsatisfied. So we don't think that the problem is the data itself. We think the problem is the structure. So to answer the question, we are very quick because we focus on the structure of the database and do not have to, we're not bogged down by the data.
Okay. I'd like to just take a minute now to remind people that there's still time to submit questions for Robert and Carrie. We'll get to as many as time allows, but some very good questions coming in. Somebody who referred back to something you had mentioned about storing database changes along with changes to source code to keep everything in sync. And the question was, how does that work?
Okay. You know, I think, you know, I'm going to answer the question from a process perspective. Simply put, the development team is going to have their repository in place. And what we would like to see is alongside that code, in a standard, and Java is something I'm more familiar with, so I'm just going to stick with that. You're going to have, a source directory that's going to have, all of our, our Java, our classes in there, all of our Java files. And you might have other directories in there, maybe a bin directory for, shell scripts, things like that, a Maven file, Ant, who knows. What we would like to see is a DB or database or Datacle or whatever you want to call it, a place where those database changes, and in this case, where your change log would be checked into. I know some people are reticent to give everybody access to the repository itself, so you can use the security that your repository, your source code control repository, has to limit access to that directory if you want. And as you go through the software development lifecycle, you'll get to a point where you will tag that at that point in time as release number 7. And we'll take release number 7 and we'll push it out to QA and then out to production. Now imagine we push it out to production and then the dev team starts working on release 8. But we find out that there's an issue in production that we need to quickly take care of. So what we will do is from that release 7 tag, we will branch and we'll create a release 7.1 release that we can then push out to QA and then to production while the dev team is working on 8. And then once we push it out to production and we're happy that that resolved the issue, we can then take advantage of all the tools that we have in development to merge that change down into the release 8. Maybe that's the main trunk or maybe that's its own branch. What that allows us to do is then take advantage of any changes that we made on 7.1 to push it into 8. It allows us to restrict access to folks that need access to the database changes but not to the code. But all the infrastructure that our development team has built, the operations team can then take advantage of. And I think that that is really the promise of DevOps, that by allowing people to start peering into their domains of influence, we then start becoming more efficient, and as an organization, we become very much high-speed, low drag.
Absolutely. Yeah, that's spot on. Very good. Okay, I have one more question here. I'll throw it out to you now. It's about stored procedure code. Is there support for it? And how do you manage the dependencies between stored procedures and tables to identify where changes might break something?
Really good question. The stored procedures, in fact, today we do not have the ability to snapshot. We certainly have the ability to push them out to make a change. And very quickly, in a matter of weeks, we are going to have that functionality. Working on it right now. But managing the dependencies is actually pretty easy because what we do is when we snapshot, we will collect all of the tables first, and then sort of build up that model from the tables then going forward. So we add, first we will, by default create tables when we have that snapshot. We will create any kind of constraints and start building up. And the last thing that we're going to push out are our stored procedures. Now, if for whatever reason you run into an issue where there is a dependency problem, let's say you have a change set that is creating a stored procedure, but you have yet to create the table. Maybe that's the next change set in your change log. Because you have the consistency of deploying the same way you're deploying to dev is the same way you're deploying to QA, the same way you're deploying to production. You are going to start catching these issues a lot earlier in the process. And as we all know, the sooner we catch bugs, the easier they are to resolve and the cheaper they are to resolve. So, two things. One, because we can order how these change sets are created, we can solve that dependency management problem for you. But because you're going to be testing these things first, because testing these things first in dev and QA, you're going to hit these dependency issues first, if at all. And you'll be able to resolve them very quickly, so that should decrease the likelihood of these kind of problems occurring in production where they're the most disastrous.
Excellent. Okay, I'd like to thank everybody for submitting their questions. Looks like we have one more. Robert, I don't know if you can see this. I'm going to try to read it and make sense of it, but if you can see it in your console and read along, and hopefully.
From? What's the name?
Nancy is the questioner.
Yeah.
So, with the software repository for code.
Yeah,
I was wondering how it works, basically, if the code is pulled, into Datical and firmware, and if there are interfaces with some of these other tool sets.
Really good question, because everything's a good question. But I especially...
They are good questions.
I think this speaks to our philosophy of how we work on our integrations, and that is play well with others, okay? We do not have our own repository. We leverage whatever the customer has today. So whatever repository you have, we can integrate with that. And that's what we want to do. We want to integrate with your existing source code repository, whether that's Subversion, CVS, TFS, you name it. We do not want to force our customers to change. We certainly wanted them to change the mechanism by which they update their database, but we want to do it in a way that leverages the infrastructure and tools that they have today. So regardless of what build system you're using, any kind of test automation system, the Mercury tools or something you've built yourself, or even your deployment tools, whether you're using Puppet, Chef, maybe the larger stuff from our HP, BMC, IBM folks, or Microsoft. We want to be able to fit into what you have today and not force you to create a Datical server or change the way you do business. We feel that the database changes are a very small part of what people do day to day, but they have a kind of a larger impact if things go wrong. And that's what we're trying to balance out.
Excellent. All right, so we're right up against it. Robert, I would just throw it out to you and Carrie if you have 60 seconds for some final thoughts or summations, a key takeaway that you would like folks to have.
Well, thank you for that. At the end of the day, I would hope that folks would look at their database changes and realize that this is something they can get a handle on. This is not something that we need to continue doing business the way we are doing it just because we've always done it that way. There's an opportunity here to really speed our time to market and how we resolve problems and deploy code. And I would encourage everybody to take this as a challenge and an opportunity to improve their business and to have an immediate impact on their bottom line from the IT department.
Excellent. All right. Well, this has certainly been real eye-opening for me. I mean, we certainly hear from the developers we talk to about these problems all the time, but the way you address it and DataCold-DB addresses these issues really kind of points up to how important this whole database change management segment really is. So let me thank Robert Reeves, CTO of DataCold, and Carrie Benge, Vice President of Operations, for a great presentation today and a great demo. I'd certainly like to thank DataCold for sponsoring today's session, and I would like to thank all of you attendees for hanging in there with us and spending your valuable time with us. So until the next one, I'm Dave Rubenstein, editor of SD Times. Take care, everybody. So long.